So question 2 here in the book, we says it's got the triangle there, list the other line segments. So we know that for a triangle, whenever the midpoints are connected, so that's equal to that, and that is equal to that. So when the midpoints are connected here, these two lines are parallel. So you've got to look at this diagram here and find out which lines are the midpoints that connect, and list, B says list the lines segments. Now going back to A, I've missed A, verify that DE and BC are parallel. So you've got to find point E and point D, find the slope between the two. So slope of DE and then the slope of BC, and if they're equal, they're parallel. And then B, list the other line segments that are parallel, because there's a couple of more lines here that are parallel to the lines of the triangle. Verify that DE equals BF, so therefore we have to find the length of DE by the distance formula, and then the length of BF by the distance formula. So all these three midpoints, we've got to find the coordinates. So C, distance, or sorry, length of, so length of two lines, DE and BF, and use the distance formula for that. And D, list the other line segments that have equal length. So go into the diagram and find the lengths that are equal. Question 2 here gives you the diagram, verify that PQ, and PQ is down here, this line here is PQ, is twice the length of ST. So you've got to use the distance formula. So length of PQ, you've got to find that first by the distance formula, and then the length of ST by the distance formula again, and that should prove that one is twice the other. Question 4, verify that ABC is isosceles. Well, how do you do that? You find the three lengths of the triangle using the distance formula, and of course D equals the square root x2 minus x1 squared plus y2 minus y1 squared. Okay, find the three lengths, and isosceles will be at least two of them the same. So if two of them the same and the third isn't, it's still isosceles. If all three are the same, it's still isosceles, but it's also equilateral. Verify, and B says verify that the median from vertex B is also an altitude. So you've got to find the median here, and that is by finding the midpoint. So find the midpoint of AC. So midpoint of AC. And now how do you prove that it's also an altitude? So let's just call that, say, point M. So now to prove their altitude, you've got to prove that BM is perpendicular to AC. And you do that by finding the slope of each line. So slope of BM and the slope of AC, and if they're perpendicular, they will be the negative reciprocals of each other. Okay, so find both slopes of AC and BM, and they should be negative reciprocals if they're at right angles, because the question's asking is that median also an altitude? Does it cut at right angles? Question 6 here, find the lengths of the sides DEF. Well, that's the distance formula. Well, that should be easy. Just use the distance formula for each length. d equals square root of x2 minus x1 squared plus y2 minus y1 squared. Find the slopes of the triangle, easy. Again, use the slope formula. And then C says classify triangle DEF. So what you're going to find is that from A and B, you're going to get information that's going to lead you to what type of triangle it could be. Well, it could be a scalene triangle. That's where all sides are different. Isosceles triangle. That's where two sides are the same. An equilateral triangle. That is where all three sides are the same. Or of course it could be a right triangle in combination with the three up above, and that would be when two slopes are negative reciprocals, i.e. you've got a right angle in there. A few questions here. Question 7, draw the triangle. Let's just draw a quick triangle here, see what it looks like. So 8, 8 is about there. Negative 5, 5 is about there. And 5, negative 7 is about there. So the triangle looks something like this, where that is J, that is K, and the other one is L. What type of triangle does it look like? So you have to make a guess of what triangle it looks like. That's A. And B, C is use analytic geometry to verify your classification. So you've got to find, in this triangle here, all three lengths and all three slopes. Determine the perimeter. It should be easy because you find the three lengths. And then D, well, we haven't got many formulas for the area of a triangle. The only one we got is for a right triangle. So possibly this is a right triangle, and you'll find that out by the slopes. Question 8, again, draw the 3 points. Let's do it very quickly. Let's do it in a different color. Negative 12, 6, about there. 4, 0, about there. And negative 8, negative 6, about there. So we've got 3 points of the triangle. And you've got R, Q, and P. Okay. Determine the coordinates of S, the midpoint of PR. So that's going to be point S. And T, the midpoint of PQ. So T there. So we know that that is equal to that, and that is equal to that because they're midpoints. And there says verify that ST is half the length of QR. So you've got to find the length ST by the distance formula, and you've got to find the length of QR by the distance formula. Questions 10 and 11, very similar. Try them, sorry, 10 especially, and then 12, have a go at that one as well.